Let's look at November 2019 Chief Mate's Stability question number 1. It says a box shaped vessel floating on even keel in salt water has following particulars: length 130 meters, breadth 22 meters, draft 7.6 meters, kg 9.80 meters. There is an empty watertight aft end compartment, length 15 meters, height 6.3 meters, extending the full width of the vessel. Calculate the drafts forward and aft if this compartment is bilged. So this is the diagram. This is the length of the vessel, 130 meters. This is the breadth, 22 meters. This is the waterline. So this is the draft of the vessel, 7.6 meters. This is the aft end compartment's length, 15 meters. The height of the compartment, 6.3 meters. While solving this question, we will assume kg constant, displacement constant, underwater volume constant. We use the formula buoyancy lost equals to buoyancy gain. So buoyancy lost is equals to length of the compartment bilged multiplied by breadth of the compartment bilged multiplied by height of the compartment bilged. So looking at the diagram, this is the length of the compartment. As this extends up to full breadth, so this is the breadth of the compartment and this is the height of the compartment. So buoyancy loss is equals to buoyancy gain. So buoyancy gain is length of the vessel multiplied by breadth of the vessel multiplied by sinkage. So length of the vessel is 130 meters, breadth is 22 meters and multiplied by sinkage. We simply put in the values in this formula and we get this following equation. From this equation, we find out the value of sinkage as 0.727 meters. Draft bilged is equal to initial draft plus sinkage. We know our initial draft was 7.6 meters here, so this has come to here, and sinkage as 7.727 meters. So this has come from here. So our draft bilged is equals to 8.327 meters. This is the first step. The second step we need to find out is the change in BB dash with respect to longitudinal and vertical extent. So first we would be finding out BB dash with respect to longitudinal extent. This was our initial center of buoyancy of the vessel, and this is the small b, which denotes the center of buoyancy of the compartment which has been bilged. Now initial longitude center of buoyancy is equals to length divided by 2 as vessel is on even keel. This thing can only take place when LCG is equals to LCB and vessel is on even keel. So since the vessel was even keel, so longitudinal center of buoyancy would be half of the length. So we divide the length, which is 130 meters, by 2 and get the longitudinal center of buoyancy initial as 65 meters. So we know that this longitudinal center of buoyancy is 65 meters. Now what we need to find out is the small longitudinal center of buoyancy of this compartment. So length of the compartment is 15 meters. So longitudinal center of buoyancy would be half of 15 meters. So we make the table to find out the final longitude center of buoyancy. So we have made the table with description, volume, longitudinal center of buoyancy in meters, and moments. So initially, my initial volume is length times breadth times the bilged draft. So this is length, this is the breadth, and this is the bilged draft. Be careful on this aspect. This always needs to be the bilged draft. I know my initial longitudinal center of buoyancy, which is 65 meters, which has come from here, and the moments. So moments is obtained by volume times longitudinal center of buoyancy will give us the moment. We know the loss due to flooding of the compartment. The volume of that compartment is, length is 15 meters, this is length. The breadth is 22 meters since it's extend up to its full breadth, this is 22 meters, and height of 6.3 meters. So this is 6.3 meters because this is a watertight flat. And the LCB of the flooded compartment is half of its length. So length is 15 meters. So half of 15 meters will be the longitudinal center of buoyancy of that compartment. So we need to take this out from this to get our final effective moments. Now my final volume would be equal to my initial volume. So I can simply write it as my length times breadth multiplied by my initial draft. You can do it the simple mathematical way by multiplying all this thing together and then taking out all this thing from this value. So my LCB final would be equals to sum of all moments, which is this, divided by sum of all volume, which is this. So I will just change and put in the values. So my sum of moments comes from here. My sum of moments come from here and my volume comes from here, which gives me the final LCB of 70.500 meters. Next step is to find out the BB dash with respect to longitudinal center of buoyancy. So our initial LCB and final LCB, these are the two values. If we take them off from one another, we will get the final BB dash with respect to the longitudinal extent. So our LCB final was 70.500 meters, which has come from here, and 65 meters is the half of the vessel's length. Now we know that change of trim is equals to trimming moments divided by MCTC, but we don't know the MCTC. And MCTC is equals to displacement times GM divided by 100 multiplied by the LBP. We don't know this GM longitudinal. And we know KM longitudinal is equals to KB plus BM longitudinal. We don't know this BM longitudinal. Now we will solve the equation and find out the BM longitudinal. We know that BM longitudinal for a box-shaped vessel, I again emphasize BM longitudinal for a box-shaped vessel is equals to length cube multiplied by breadth divided by 12 and divided by volume. So I'll just put in the values here, and I have obtained my BM final as 185.307 meters. Again, to 3 places of decimal. Next step is to find out the KB. We have found out the BM longitudinal. Next step is to find out the KB so as we can find out the KM. Now in this case, since the compartment, if you look here, this is the compartment which has been flooded. If this entire compartment would have been flooded, or I would say if there would have been no watertight flat, then I could have simply written KB bilged would be equals to draft by 2, which is draft bilged. But in this case, there is a watertight flat. So KB bilged will never be equals to draft bilged by 2. We need to solve it with the tables. Again, the table is with description, volume in meter cube, KB in meters, and moments. The initial volume is 130 multiplied by 22 multiplied by 8.327. So this is the length, this is the breadth, this is the bilge draft of the vessel. So this is the length, this is the breadth, and this is the bilge draft. Now, as we did here with respect to the longitudinal extent, we found out that LCB is equals to half the total length of the vessel. Same way, the KB initial would be half of the initial draft of the vessel. So we know that initial draft of the vessel is 7.6 meters here. So half of 7.6 meters will be 3.8. And I have got this moments by multiplying volumes times the KB. Now I need to take this loss due to flooding, as this entire compartment has been flooded, so this needs to be taken out. This is not providing buoyancy anymore. So the dimensions of the compartment is length is 15 meters, breadth is 22 meters, and height is 6.3 meters. And the KB is again half the height of the compartment. So height of the compartment was 6.3 meters. Half of 6.3 would be the KB of the compartment. So the moments would be taken off from this value, and the volume of the flooded compartment would be taken off from the volume of the bilged vessel. So finding out the total volume, I got an answer of 21736.22 meter cube and moments as 83948.9 meter to the power of 4. In this case, the unit of moments is meter to the power of 4 because we are multiplying meter cube times the meter. So meter cube times meter gives us meter to the power of 4. So sum of all moments divided by sum of all volume will give us the value of KB bilged as 3.862 meters. Now I know my KB, I know my BM longitudinal. The KB bilged what we found out was 3.862 meters and BM longitudinal is 185.307 meters. So if we see this B, this has moved further forward and further above. So we have found out the KM longitudinal, which is KB plus BM longitudinal. Now we know that KM longitudinal is equals to KG plus GM longitudinal. Be careful about these longitudinal values. So KM longitudinal is 189.169 meters. KG is 9.80 meters, which was given in the question, and we have got this equation. From this we have found out GM longitudinal as 179.369 meters. Since we were asked to find out the drafts, so the drafts would be different at forward end and aft end. So to find out the drafts at the forward end and aft end, we need to find the trim, and trim depends upon the MCTC, which is moments required to change trim by centimeter. So MCTC is equals to displacement multiplied by GM longitudinal divided by 100 times the LBP. So we put in the values. So displacement of the vessel is length times breadth times the draft multiplied by density in which it is floating times the GM longitudinal, which has come from here, and divided by 100 divided by the length of the vessel, which is length between the perpendiculars. We have found out the MCTC to be 307.4 tons meter. This is the unit. Change of trim is equals to trimming moments divided by MCTC. Trimming moments is nothing but BB dash, which is with respect to the longitudinal values, multiplied by the displacement divided by MCTC. So BB dash we had found out initially was 5.500 meters, which was here. So 5.500 multiplied by the displacement of the vessel, which is length times breadth times the draft initial times the density in which it is floating, divided by the MCTC. We got the change of trim as 398.6 centimeters or 3.986 meters. Our answer, what we will be obtaining from solving this equation, will give us the answer in centimeters because we are using MCTC. So MCTC gives answers in centimeter. As its definition stands, it's moments required to change trim by centimeter. So change of trim is equals to 398.6 centimeters or 3.986 meters. Now we are supposed to find out the LCF bilged. Now LCF bilged will be equals to LCF initial because there is no change in water plane area of the initial condition and final condition. If we look at the diagram, when vessel was floating and the compartment was not flooded, this was our draft and this was the length of the vessel, this was the breadth of the vessel. So our water plane area is length times the breadth. When the vessel got flooded, this became our final water line and our intact length still remains the same and the breadth still remains the same. So water plane area, as the formula of the water plane area is length times the breadth. So from this thing we can say that the water plane area hasn't changed. So the longitudinal center of flotation remains the same because longitudinal center of flotation is the geometric center of the water plane area. Now LCF bilged is equals to LCF initial because there is no change in the water plane area. And LCB is equals to LBP divided by 2 times LBP divided by 2, which gives us 65 meters, which was our initial LCB, which we had found out initially. And this is because the vessel is on even keel. So if the vessel is on even keel, like I have explained it before, the LCB will be equals to LCG and they will be exactly, LCB and LCG will be exactly at the same point. Now trim forward is equals to trim aft since the LCF is at the center. So trim forward is equals to trim aft is equals to trim divided by 2. Now we are trying to find out what will be the change of trim forward and what will be the change of trim aft. So we can find it out by dividing the trim, which is this value, divided by 2 because LCF is midship. So trim forward is equals to trim aft is equals to 3.986 meters, which has come from here, which gives us 1.993 meters. Now we have made a table which says draft forward and draft aft. True mean draft of the bilged vessel was 8.327 meters, which is same for forward and aft. True mean draft remains same. That is the draft of the vessel at the longitudinal center of flotation. Now since this center of buoyancy has moved forward, So this is going to have a lever formed because the center of buoyancy is going to act like this, and the center of gravity, which hasn't changed, is going to act like this, and the vessel is going to trim like this. So which means that this is going to be our final water line. So our forward draft is less and our aft draft is more than the midship draft. So we can, from the above drawing, we can find out that the change of trim forward, which we had found out here, has to be taken off from the true mean draft, and change of trim aft has to be added to the true mean draft. So we take trim of 1.993 meters from the true mean draft of the bilged vessel of 8.327. We get draft bilged of forward draft as 6.334 meters, and we get the aft draft in bilged condition as 10.320 meters.